Hi everyone, so this is still in section 5.2, which was properties of exponents within the radicals. So we're just going to work a little bit more with radicals. You'll see the exponents come up more, but this is our second day in this section. So today in this example, we are going to multiply radicals. So some things that we need to know about multiplying radicals. In order to multiply radicals, we need the same index. So remember, index is this number right in that little corner of a radical. So these two, I can't multiply them together. If the problem told me to simplify this expression, I can't do it. There's nothing for me to do when my indexes aren't the same. And then once I have the same index, or if I have the same index, then we just multiply the radicands. Okay, so we're going to look at this in a second, but we leave the indexes the same and we multiply what's under the radical. Remember vocab, that's called the radicand. Okay, so we're going to do this example. And it says, what is the reduced radical form of the product? So we just have to multiply these. Take a look at this. I have the cube root of 7 times 2 minus the cube root of 49. Any ideas on what we can do? Or does this kind of look like something that we've been doing, maybe not with radicals, but we've done before? Take a look. What do I do when I have a number out front of parentheses? We distribute. Yay! So we're going to take the cube root of 7, multiply it to the 2, and multiply it to the cube root of 49. So what that looks like is here, okay? Remember, when we multiply with radicals, I need the same index. We can kind of treat that like it would just be like an x. You know, if I can't multiply these two together, I'm just gonna write like 2x, but here I have 2 cube root of 7. So when I can't multiply them all, we just write them next to each other, and the number goes first. So that's what happens when I distribute the cube root of 7 to 2. And then I need to distribute the cube root of 7 to the cube root of 49. So remember, when we multiply radicals, I need the same index. So do I have the same index, right? They're both 3, they're both cube root. And then once I have the same index, I just multiply what's under the radical. Okay, so I'm going to have cube root of 7 times 49. Okay, and that's what I get when I distribute the cube root of 7. From here, we just have to simplify. So 2 cube root of 7 doesn't simplify at all. I can multiply 7 times 49, and it's going to give me 343. And then I'm going to think, well, like, can I do this? Can I take the cube root of 343? Is there something that I can multiply by itself 3 times to get 343? Anybody know what that is? That's going to be 7. Okay, so I can simplify cube root of 343 is 7. That goes back to 5.1. Okay, and here's our simplified form. We did it. Awesome. Let's take a look at another type of multiplication. So before we do the multiplication, we're going to need to review how to add and subtract radicals. In order to add and subtract radicals, now we need the same index and radicand, and then I just add and subtract the coefficients, whatever number is in front of the radical. So this would represent our coefficient, okay? So here's this example. What do you think we should do? I have 2 binomials being multiplied together. How do I multiply? What's the process we go through to multiply 2 binomials? It's going to be FOIL, your favorite. Okay, so we're going to go through and FOIL this. Let's see what we have to do. 2x times 2x. That's going to give me 4x squared. Then I'll have 2x times negative square root 3. Nothing I can multiply, so we just leave it as negative 2x square root 3. We put the number before the radical. And then I have negative square root 3 times 2x, so I'll have negative 2x square root 3. And then the last one, I'll have negative square root 3 times negative square root 3. So here's the multiplication of radicals. I have the same index because they're both square root, right? Square root, square root. So all we do is we multiply the radicands together. 3 times 3. A negative times a negative gives me a positive. From here, we just simplify. So I can simplify like terms. What are my like terms? My like terms here, what color? My like terms here are the x square root 3, right? These are the same exact thing, and I can combine these coefficients. -2 minus 2 gives me a -4 x square root 3. Those are the same, and that's what comes into play here. How do I add and subtract radicals? They need to have the same index and radicand. These are both square root 3. They both have the same amount of x's, so we can combine them. And I also multiplied 3 times 3 gives me 9. Last thing for me to simplify is that square root of 9. I know the square root of 9 is 3, and that's my simplified form. Okay, so this is how we multiply when I'm dealing with radicals. We have thrown in there some other things to recall about adding and subtracting radicals and multiplying radicals. Okay, the last example for 5.2 looks like this. So we need to, let me go like this really fast because that was a lot to look at, right? Last example is we need to rationalize our denominator. So this came up before. What does rationalize a denominator mean? It means that I am not allowed to have a radical in my denominator. It's bad math, okay? So when I see something that looks like this like hurts math people's eyes. I cannot have a radical in my denominator, okay, because it will give me an irrational number. So I need to rationalize it by multiplying by the conjugate, okay? And that's the process that we need to go through. To rationalize a denominator that has a binomial, right, 2 terms denominator, this is the process and you need to write it down. Multiply by the conjugate of the denominator. What is a conjugate? If the binomial was a plus b, the conjugate is a minus b. All you have to do is change the sign. Okay, so in this case, it's 2 plus square root 5. The conjugate of 2 plus square root 5 is 2 minus square root 5. Notice like the positive 2 doesn't become a negative 2. It's just the sign between the 2 terms in the binomial. So that's what we have to do. If this, for example, was a final answer, I can't leave it like that because of that square root in the denominator. So before I say, oh, this is the final answer, I need to rationalize it. And how we're going to rationalize it is by multiplying the numerator and the denominator by the conjugate of the denominator. Change the sign. So I multiply the numerator and the denominator by 2 minus square root 5. So now we kind of just look at this going straight across, right? 1 times 2 minus square root of 5, well, that's just going to give me 2 minus square root of 5. Down here, though, 2 plus square root of 5 times 2 minus square root of 5. Well, here's where the foiling that we just learned comes into play. So then we're going to have to FOIL. 2 times 2 gives me 4. 2 times negative square root 5. Can't combine, so negative 2 square root 5. Square root of 5 times 2 plus 2 square root of 5. Square root of 5 times negative square root of 5. Same indexes, so I multiply the radicands. And then I'm going to simplify. When I simplify, these are going to cancel, right? Same radicals, same radicands, negative 2 square root of 5 plus 2 square root of 5, that's going to become 0. And I'll be left with 5 times 5 here is 25. I can simplify this more. The square root of 25 is 5, right? And I can do it one more time. 4 minus 5 simplifies to negative 1. This is the answer that we would want. And this is better math because notice by doing this whole process, multiplying by the conjugate, there's no more radical in my denominator, and that's what I wanted. I rationalized this fraction, made it better by getting rid of the radical in my denominator. Okay? Just a little thing to make our math a little bit better. So you guys are going to practice both of these things, multiplying and rationalizing the denominators, okay, in the practice section. Awesome job, guys. Thank you so much.